How do block diagrams simplify transfer functions? Imagine trying to understand a complex machine by looking at all its parts at once. It can be overwhelming and confusing. That's where block diagrams come in. They act like a map, showing how different parts of a system connect and work together. In control systems and signal processing, transfer functions tell us how a system responds to inputs. But when systems get complicated, calculating the overall transfer function can be tricky. Block diagrams help make this easier by breaking the system into smaller, manageable pieces. Each piece is represented by a block that shows its transfer function. These blocks are connected with arrows that show how signals flow from one part to another. This visual setup helps engineers see the entire system at a glance. It also makes it easier to analyze and understand how each part affects the whole system. One big advantage of block diagrams is their modular nature. Instead of trying to analyze the entire system at once, engineers can focus on individual blocks. Each block has its own transfer function, which is like a mini recipe for how that part behaves. Once these smaller transfer functions are known, they can be combined to find the overall transfer function. For example, if two blocks are connected in a line, their transfer functions multiply. If they are in parallel, their transfer functions add. And if there is a feedback loop, special formulas are used to adjust the transfer functions accordingly. This step-by-step process makes the math much simpler. Another benefit is that block diagrams help handle systems with multiple inputs and outputs. Engineers can isolate each input and see how it influences each output. They do this by setting other inputs to 0 and analyzing one at a time. This makes complex systems easier to understand and design. Instead of dealing with complicated differential equations directly, engineers work with algebraic transfer functions. This shift makes calculations faster and less prone to errors. Block diagrams also make troubleshooting and designing control systems easier. By visualizing the system, engineers can quickly spot feedback loops, summing points, and signal paths. This helps in tuning controllers or fixing issues. In electrical engineering, block diagrams are used for designing motor controllers, filters, and communication systems. They help engineers predict how a system will behave and decide what adjustments are needed. In short, block diagrams turn complicated systems into simple, visual models. They help break down, analyze, and combine transfer functions efficiently. This makes designing and understanding control systems much more straightforward and less stressful.